Okay, so if you are getting ready to take a college level math course, or maybe you already are in a college level math course, and I'm talking about courses like pre-calculus and calculus, well, you definitely need to understand this right here. And what we're talking about in this video is something called polar equations. And again, you will definitely see this at a college level of mathematics. All right, now this is typically taught in advanced trigonometry, and that is typically a part of a course like pre-calculus. But whether you study this in a trigonometry course or a pre-calculus course, you need to understand polar equations because you will see this, as you continue on or continue on in mathematics in college. All right, so what we're going to do in this video is take a look at my full polar equations lesson from my pre-calculus course. Now, that lesson is well over 1 hour, but I'm going to give you the part of the lesson that gives you a nice introduction to polar equations. So if you need help with polar equations or anything at this level of mathematics, check out my full pre-calculus course. I'm going to leave a link to it in the description of this video. All right, so let's go ahead and get started right now.
Okay, welcome to the video on polar equations. This will be a lesson on this topic. And just a little forewarning here, this particular topic is what I would kind of classify as advanced mathematics. So I'm expecting you to have already learned and mastered all the kind of prerequisite knowledge for this particular topic. So you need to be very strong in trigonometry, all the foundational stuff that comes, at least in my courses, before you look at polar equations, and that would include conic sections as well. So all your algebra prerequisites and trigonometry prerequisites, all this kind of comes into play because you're going to be learning a lot of new concepts in polar equations, and it can get somewhat confusing. Okay, so go back and review what you need to review, and just take your time. This is going to be a pretty long lesson, and obviously you might want to even look at it twice or get what you need to get after the first time you look at this lesson to make sure everything is in your notes. Okay, so with that being said, let's take a look at our objectives here. So we're going to learn what the polar coordinate system is, and then we're going to go ahead and learn how to plot points in the polar coordinate system. And then we're going to learn polar to rectangular conversion. So we're going to learn how to take a point that's in polar form and write it as rectangular form and vice versa. And then we're going to learn how to graph polar equations. And then we're going to list and learn basic functions in the polar coordinate system. Then lastly, we're going to learn how to convert equations from polar to rectangular. So got a lot going on here, but it just makes sense to kind of encapsulate everything into one lesson. All right, so we got this word polar, right? Let's just kind of look at this word real quick before we get into the formal lesson. So you might be thinking to yourself, here's Earth and here is the North Pole, right? You're like, hey, is that what we're talking about? Well, yeah, kind of, sort of. We are talking about that because if you were standing on the North Pole, directly at the North Pole right here, and you wanted to find a location, okay, that was right here at the North Pole, you would be like, well, how do I do that? Well, one of the ways we can kind of think about that is using polar coordinates. So if we can kind of give some sort of angle and then some sort of radius out or distance out to that point, that's one way to describe a point kind of on a sphere, right? Another way to think of polar coordinates, okay, and this is kind of leading you to the formal definition of all this stuff, is like a radar screen, like on an airplane or a ship. So in the middle, you got this little thing sweeping around, it's going, making its noise, beep, beep, and then you hear like a little blip, boop, and you get something on the radar screen over here or over here. So we determine the location of the ship or airplane is in the center. Okay, so what we do is we get a distance out to that target, if you will, and then some sort of angle, okay, that we can reference to that. In essence, this is what we're talking about here, polar equations. So let's get to it. So up to now, okay, we've been using the good old-fashioned, not old-fashioned, but the good old dependable rectangular coordinate system. Okay, so if we wanted to plot a point, okay, let's say we have a point P here, and I wanted to say, hey, what's the location of that particular point? Well, I can just use my XY ordered pairs to get there, right? So this point could be, for example, the ordered pairs 4, 5, right? So that's our system, and this is the rectangular coordinate system, and it works very well. Okay, it's very useful, and we want to, keep this system, right? But the polar coordinate system comes in handy with, in terms of some of those examples I described to you, right? Like on a radar screen, or, talking about navigation on a sphere or something like that. We need a different type of coordinate system, and that is the polar coordinate system. All right, so let's first talk about how we can define this particular point. So here again on the rectangular coordinate system, we can just describe the precise location of this point by using ordered pairs. But in the polar coordinate system, we do something different. Okay, what we're going to do is we're going to have an angle. Okay, we're going to give somebody an angle, right? Just think of it, hey, look, this point P is located at some angle and then some radius out, some distance out from some fixed location. So this fixed location is called the pole. Okay, and then we kind of need to form an angle. So this first leg of this angle here is what we call the polar axis. Right, and then we have a terminal side, and it's going to go through this point P. Okay, so I can say this point P, okay, is at this distance, this radius here, okay, and this angle theta. Right, so that is how we describe a point in the polar coordinate system. So for example, here's this point P. Okay, here's my polar axis. Here's the pole. And this angle here is 45 degrees, and this distance out here is 3. Okay, so this point is at 3, 45. So the form of a polar coordinate is this, r theta. Okay, r being the radius, the distance out from the pole, and the theta being the angle in standard position. In other words, well, this is going to be the polar axis, but you're going to see here in a second, this is going to be the x-axis. So we'll get into this more precisely, but that's the essence of what the polar coordinate system is. All right, let's move forward. Now, this can be confusing, what I'm going to get into, right? So I just gave you kind of the basics of the polar coordinate systems, and now we're going to talk about how to plot points in the polar coordinate system. Well, I just showed you an example, but we're going to really kind of make this more precise. So here is kind of like our XY plot, okay? And these little circles here just help us define what the radius is. So like here, there's 1. Okay, so this circle, anywhere along this circle has a radius of 1, right? Just going to help us define points, because remember, to describe a point with polar coordinates, we need that radius, okay, and a particular angle. Now, the polar axis, right, where we start forming an angle is going to be the x-axis. Okay, that's the polar axis. The pole, okay, remember we need a pole, is the origin, right? So that's going to be the pole. Okay, the x-axis is the polar axis, and then we're going to go ahead and just describe angles either by positive or negative angles. So all this stuff you should be familiar with, right? So again, go back up here. The polar axis for us here, and this particular thing I'm going to get into here, is the x-axis, right? And the pole is at the origin. Okay, so let's start off with some easy coordinates here. So let's just kind of just focus on what I'm doing here one at a time, and then of course you can pause the video and take your notes. So let's look at this point right here, right? That point is at 2, and I'm using radians here, 2, 5 pi over 6. So 5 pi over 6, remember, it's always the radius, okay, and then the angle. The angle could be in degrees or radians. So 5 pi over 6 is equivalent to 150 degrees. So 150 degrees for an angle in standard form is going to be, here, I'll just kind of roughly draw it. It's going to be like this, right? All right, that's terrible. Let's try that a little better. Okay, so it goes past 90 degrees, and that's like a roughly 180 degrees in standard form. Okay, that angle is in or standard position, excuse me. So it starts at the x-axis, okay, and then this is my terminal side. Okay, this is the terminal side of that angle. This is 150 degrees. So it makes sense, okay? So from here, this angle opens up like so and stops there. And then our radius is at 2. Okay, so it's going up from the origin, okay, the pole, out to 2, and there is my radius. Okay, so if you can kind of just study that, make sure you understand that. Okay, if I was to draw this out, you would see, okay, that's 150 degrees, 2. By the way, some things that you definitely want for this lesson would be like a protractor, a ruler, things like that. Definitely comes in handy, and a graphing calculator. A minimum, you need a scientific calculator for this level of mathematics for sure. Okay, so that's a pretty easy example. Make sure you understand that, because some of this other stuff here can get very confusing. Let's start with this guy, okay? Now, here, the radius, all right, if you look here, the radius is negative. So what does that mean? Okay, well, I'm going to explain that in a second. And the angle theta is pi. So pi, all right, you should know, is 180 degrees, right? So we're starting from the polar axis. Use a different color. We're sweeping around 180 degrees, or pi. Okay, that's positive, right? So it's going counterclockwise. Boom. But instead of landing here at 3, okay, I'm saying that this coordinate, this polar coordinate, is here. So we might say, well, that's a positive 3. What's that? You just look here. I'm saying this is the coordinate. It's a positive 3, not negative 3. Now, the reason why that is when I went pi units this way, I did land on a negative 3, okay? I went from here, boop, I landed on a negative 3, and this location would be pi positive 3. When you put a negative sign in front of a radius, it flips, okay? So in other words, I went from here to here, all right? That would have been 3, but as soon as I made it negative, it goes the opposite direction, whoop, that way, okay? So this angle, instead of being 3 here, it gets reflected, if you will, back over to this 3. Okay, I know that's confusing, and it can definitely be confusing if you don't understand that. Okay, so the negative sign basically shifts the ray to the opposite direction, and that's many units. So here, instead of going out this way 3, it's going to be up, going out the other direction. That's how we end up with this location here. Okay, all right. Let's talk about another point. Okay, how about this guy right here? All right, so the radius is 1. Okay, that's no big deal. But the angle is negative pi over 2. All right, so negative pi over 2 is negative 90 degrees. So I'm going counterclockwise. Okay, so I'm going counterclockwise. I'm just going out 1. All right. Now, although this is a negative 1 here, you don't have to worry about that. This is the point that we're referencing to. But that same point can be described by this polar coordinate, okay? Negative 1, 450 degrees, all right? So let's see how that would work. So 450 degrees, that's a positive angle. So I would go this way, right? All right, so I would start here on the polar axis. I would go around. I would do a 360, okay? And then I would continue around another 90, and I would get to 450 degrees. So I would end up here, okay? That would be my point, but I want to describe this point. I want the location of this particular point right here. Well, that would be 450 would land me right there, so I could put a negative in front of that to make this point go down here, okay? So I'm going in the opposite direction. So that would be negative 1, 450 degrees. This is a point, or this one I've just shown you, is an area of confusion when you're studying polar coordinate system for students. So, this is you're going to get confused a little bit, right now you're probably saying, oh, I get it. No, but when you're plotting points, you will make little errors. You got to really concentrate and focus about these particular points until you get used to it, right? And in time, you will. All right, now let's move on to polar rectangular conversion. So we have 2 points, right? We have 2 ways of describing a point, right? So this point here, I can describe as an XY ordered pair, all right? Or using this new system, our polar coordinate system, right? So that would be a radius and angle. So you can convert between the two, right? We can go from here to here and vice versa. So let's take a look at this particular point. So from an XY on an XY Cartesian plane, right, that point was obviously at X and Y, okay? But if I want to describe this as in terms of a polar coordinate, I would start on the X-axis, right? That's my polar axis, and I'm going clockwise this many degrees. I need to get this radius, right? If I can get this radius this way and this angle, then I have a polar coordinate. Well, it's pretty easy to do, right? This is basically a right triangle, okay? So I can use the Pythagorean theorem, x squared plus y squared is equal to r squared, and just take the square root of that, and this will give me this hypotenuse. So that's pretty straightforward, okay, to get that r. And then using basic trigonometry, all right, and of course this is advanced trigonometry, but basic trigonometry, I could use the definition of sine and cosine and tangent to get these various lengths. So y, for example, is equal to r, once I had this value, times the sine of theta, okay? And so again, basic trig. So remember this angle right here. What's the sine of that angle, right? Sine of theta is equal to, what's that? So, right? Opposite over hypotenuse. So that would be y over r. So y over r. And now I have that equation. So to solve for r, okay, well, let's just do that real quick. Let's just do this. Okay. So I have sine of theta is equal to y over r. And I can multiply both sides, cross multiply by r. So that'd be r sine theta equals y. Okay, so y equals r sine theta. So this is why we can express this distance, okay, this distance here, y is r sine theta. And the same thing for x, I can express that as x equals r cosine theta, right? So this is the foundation of expressing a point as polar or rectangular, but let's kind of clean this up a little bit, all right? So if you're going from a polar coordinate, r theta, and you want to express it as a rectangular, okay, point, remember, x is going to be, this x here, this x value, will be expressed as r cosine theta, because remember, you have this information, or we're trying to write it like this, and then y would be expressed as r sine theta, okay? All right, again, I can go not only from polar to rectangular, I can obviously go from rectangular to polar. So if you're doing that, this becomes a little bit more interesting. Remember, here, okay, I'm given an xy point. Well, the first thing I need is the radius. So I can use the Pythagorean theorem, all right, as I just showed you, to get r. Now, where it gets a little bit interesting is I got to find the angle now. Well, the angle, right, this angle theta, we need to have it in standard position. All right, standard position, again, you're talking from the x-axis and you're going this way, counterclockwise, right? And this angle, this angle, when it's in standard position, this is the terminal side right here of the angle. It's got to contain that point. Okay, it's got to contain the point. All right, so let's see some examples, and this will make a little bit more sense. All right, so let's convert this point. Now, what kind of point is this? All right, now you can start getting used to it. This is a particular point. It's a polar coordinate, right? So it's 6 is the radius and 210 degrees is our angle. So we want to convert this to rectangular coordinates. So In other words, we want to go from polar into an XY, right? That's rectangular coordinates. So I'm going to need X and I'm going to need Y. So I have my two equations here that I gave you, X for X and Y. So remember, for both of these equations here, what's the inputs? We need the radius and we need the angle, the radius and the angle, and we're obviously given the radius and the angle. So it's really just nothing more than kind of plugging and chugging away here and calculating all this out. Okay, so X is going to be equal to 6 cosine 210 degrees. Now, depending on your teacher, you may or may not be given a calculator for some of your quizzes and tests. Okay, you definitely will need your calculator for other parts of the test, but oftentimes at this level of math, your teacher likes to reinforce and check your understanding that you know how to find the cosine of common angles, cosine and sine and tangent of common angles. 210 degrees is one of those. So you should have your little reference chart from previous topics that we studied in trigonometry. So this is the 6 times negative square root of 3 over 2. That's the cosine of 210 degrees. And that is going to be equal to negative 3 times the square root of 3. That's our x value. Okay, so we can write that here as our x-coordinate. And then y is going to be 6 times negative 1/2 is the sine of 210. Of course, you could just build these reference triangles and turn these into radians and figure all that good stuff out. And then when you simplify this, that becomes negative 3.
Okay, so I hope this video helped you out. And if that's the case, don't forget to like and subscribe. Now, if you need additional help in advanced math, check out these courses right here. So these courses, Algebra 2 and College Algebra, these are effectively the same level of mathematics. So whether you take my Algebra 2 or College Algebra course, you're going to get the same material. Now, if you are further along in math and you need to study like advanced trigonometry and other topics, then check out my pre-calculus course. All right, so I'm going to leave links to all these courses in the description of this video. And with all that being said, I definitely wish you all the best in your math adventures. Thank you for your time and have a great day.